Hello everyone, welcome to my YouTube channel. My name is Zane and this is my first episode on YouTube. So I decided to start with acids and bases as it was recommended by most of the learners as being difficult. So I'll try to make it as simple as possible to my best understanding. I hope this helped you a lot. And please leave a comment and subscribe to my channel because I'll be making more videos on science. Thank you. So we're going to be talking about acid-base reactions. So an acid is defined as a solution that has excess hydrogen or hydronium ions. As you can see on the diagram below, we have 4 hydrogen ions and 2 hydroxide ions. So since the hydrogen ions are more than the hydroxide ions, that means the solution is acidic. And the second one is a base solution is defined as a solution that has excess hydroxide ions. So in the diagram, we have 3 hydroxide ions and 2 hydrogen ions. So that means more hydroxide ions, therefore the solution is basic. And lastly, a neutral solution is defined as a solution that has an equal concentration of hydrogen and hydroxide ions. So in this case, we have the same amount of hydroxide and hydrogen. and hydrogen ions. That means the solution is indeed neutral. This is Arrhenius, who came up with an Arrhenius theory of defining an acid and a base. Arrhenius defined an acid as a substance that produces hydrogen ions when it dissolves in water, and it defined the base as a substance that produces the hydroxide ions when it dissolves in water. So if you add an acid into water, it will ionize itself into hydrogen ions and other parts which forms the acid itself, and the base will produce hydroxide ions. So an example is a reaction of hydrogen chloride, better known as HCl. It ionizes according to the following equation. We have HCl, which ionizes into hydrogen and chlorine ions. So if you add HCl into water, you're going to get hydrogen ions plus chlorine ions. So one thing we know is that hydrogen cannot exist as itself as a singular atom. So it will react with the water in the solution and it will form a hydronium ion. And we say that the acidic properties of the solution are due to the hydronium ion present in the solution. Okay, and another example is the base of sodium hydroxide. Sorry about that side, it's supposed to be X. Sodium hydroxide, which dissociates into ions according to the following equation, which is sodium hydroxide would dissociate into a sodium plus ion and a hydroxide ion. And in this case of the base, the ion responsible for the basic properties of a solution is the hydroxide ions. And again, another scientist defined a base according to the theory, which was later named as the lowry-bronsted theory. So in this case, the acid was defined as a substance which donates protons or simply as a proton donor, and the base was defined as a proton acceptor. So an example of this theory is that of hydrogen chloride with ammonia. So in this case, we've already established that HCl is an acid and NH3 is a base. So according to the definition, HCl is going to it's going to donate one of its protons to the reacting partner, and the ammonia is going to accept one of the protons from its reacting partner. So in this case, chloride had one proton before the start of the reaction, and at the end of the reaction, we were only left with the chlorine ion. And in the case of ammonia, the base, we had 3 protons before the start of the reaction, and now there is 4 protons after or at the end of the reaction. So you can see that we have a positive now, indicating that one proton has been added since it was neutral at this state. So we can call these two the conjugate pair. This one is the acid proton donor, and for these two, another conjugate pair, calling this one the base proton acceptor. Okay, now let's take a look at reaction equations of aqueous solutions. So the first one, let's look at hydrogen chloride reacting with water according to the following equation. So in this case, we're moving from hydrogen chloride to the chloride ion and H2O to H3O plus. So in this case, we have an acid which is hydrogen chloride. So as you can see here, we can say that we have a 0 there, or it's neutral, and also we have a 0 here, or we can say it's neutral. So we are donating a proton, or we are removing a proton from the molecule HCl, and when we remove that hydrogen, we get the negative in the chlorine. So it's like we're saying from the neutral position we are removing plus 1, which is the proton, because remember, hydrogen as an ion, it's H plus. And here again, we have 0 over here for neutral, and we are adding that one we removed from the hydrochloric acid. So that is why we end up having a positive here and a negative here, because 0 minus plus 1 is equal to minus, or you can say minus 1, and 0 plus a positive 1 equals to positive 1. So that's what gives us this plus. Okay, in this case, hydrogen chloride as an acid will act as a proton donor, and in so doing will leave the chloride ion in the solution. And another example is that of a base. One common base we've learned about was ammonia. So in this case, ammonia is reacting with water. According to the equation, we have ammonia reacting with water to form the ammonium ion plus the hydroxide ion. So here, same thing we talked about. Since ammonia is a proton put donor, we have 0 here, so it's going to be accepting a plus 1 from the proton, and we end up having that plus and the ion. And this hydrogen, this H2O is acting as an acid, it's donating its proton, so we have 0 here, and removing 1 proton, we can say removing plus 1 since the proton is a plus, so this leaves us with that negative over there. So in this case, ammonia, being a base, will act as a proton acceptor, and in so doing will leave or will form the ammonium ion in the solution. Okay, and the conjugate base pairs. When we talk about the conjugate base pairs, we're talking about the compounds that differ by the presence of 1 proton, or you can say the hydrogen ion. So all acids have a conjugate base, which is formed when they donate a proton, and all bases have a conjugate acid, which is formed when they accept a proton. So let's take a look at an example. So we're given a question stating we should indicate the conjugate acid base pairs when hydrogen chloride and acid is dissolved in water. So first we have to form the equation. So the equation is hydrogen chloride plus water, and the product is hydronium ion plus Cl. It's quite simple to form the product. It's simply the ionization of hydrogen chloride. So the solution for this problem, we have the equation HCl plus H2O giving us H2O plus the chloride ion. So in this case, we know that the hydrogen chloride is our acid, so we can label that as acid 1, and we're going to want to find its conjugate base. So since it is an acid, it's going to give away this hydrogen or this proton and will be left as chloride. So the chlorine and the product side is going to be our base. Since we've labeled the hydrogen chloride as an acid, H2O is our second base. So since a base must accept a proton, that will mean the hydronium ion is our acid. So just to get you to understand how does this become an acid and how does this become a base. So do you see these two arrows? There's one moving to the right and the other one moving to the left. This means this reaction is reversible. So you can either view it as a forward reaction in which your reactants are HCl and H2O, or a reverse reaction in which your reactants are H3O plus and Cl minus. So in the case of the reverse reaction, we have these two as reactants. So that will mean our hydronium ion started with 3 hydrogens, or you can say with 3 protons, and ended up with 2 protons. That means our hydronium ion donated a proton. That is why we consider it an acid. And in this case, our chlorine ion had no protons initially and ended up with a single proton. That means it accepted the proton, therefore it is a base. Okay, so we can connect these two, the hydrogen chloride and the chlorine ion. So these ones are our conjugate pair 1, and This is our conjugate pair 2. So just to write it in a descriptive manner, we have the first pair. The acid for the first pair is hydrochloric acid, and its conjugate base is the chloride ion. And secondly, the second pair, we have the base, which is water, and its conjugate base, which is the hydronium ion. Okay, the second one is for you to attempt. So you want to indicate or you are asked to indicate the conjugate acid base pairs when the ammonium, which is a base, dissolve in water. So you do the same thing we did and try to find your conjugate base pair. Okay, thank you for watching, everyone. Please leave a like, a comment, and subscribe to my channel. If you have any other requests, videos for me to make, leave a comment and I'll tend to it. Thank you.